Hi friends, today we shall be discussing two popular searching algorithms. A search algorithm, as we know, is a method of locating a specific item of information in a larger collection of data, which could be array, list, etc. The algorithm returns true if the item is found and false if it is not present in the list. Today we shall discuss two algorithms for searching the contents of an array: linear search and binary search. Linear search is one of the simplest and basic search algorithm. It uses a loop to sequentially step through an array starting with the first element. It compares each element with the value being searched for and stops when that value is found or the end of the array is reached. This is shown with a simple example. For example, if one has to search for 8 in a list of integers 99, 97, 18, 21, 5, 8, 64, 0 and minus 37, the algorithm will first compare with 99, then 97, then 18, 21, 5 and finally with 8 and stops as there is a match there. We now look at the performance of linear search. Best, worst and average cases. In the best case, the target value is in the first element of the array, so there is only a single comparison and the running time is order 1. In real life, we do not care about the best case because it so rarely actually happens. In the worst case, when the element we are seeking is in the last position in the array or is not in the array at all, the total number of array item comparisons performed in a linear search equals the total length of the array being searched. For an array with say 2048 elements, this means 2048 comparisons in the worst case. Thus, the running time is order n in worst case. For determining average case of linear search, we consider the probability of presence of given element at any position in the array. If the element is present at first position, then only one comparison takes place, or when element is found at second position, then two comparisons take place, and so on. In general, if an element is present at kth position, then k comparisons take place. To find the average case complexity, we calculate the average number of comparisons that may take place. The expression for average case running time is 1 plus 2 to n divided by n, which is equivalent to n plus 1 by 2. Therefore, average case time complexity for linear search is order n. Linear search trade-offs. Benefits: easy algorithm to understand and implement, array can be in any order, can work both on arrays as well as linked lists. Disadvantage: inefficient and very slow. For array of n elements, examines n by 2 elements on average for value present in the array and n elements for value not present in the array. Linear search is acceptable for relatively small arrays, but the process of examining each element in a large array is time consuming. An alternative to linear search is binary search. In order to perform binary search, an array must be in sorted order. Binary search takes advantage of this organization by using a clever but simple strategy that quickly zeroes in on the element to find. But before moving forward, we look at two real life examples of linear and binary search. Suppose you have a telephone book and you want to search for a person's telephone number. You know the person's first and last name. How would you find it? How difficult is this? Secondly, suppose you have the same telephone book and you want to find a person that has a certain telephone number. How would you do it? How difficult is this? Well, in the first case, what we do is to open the phone book at some page near the middle of the book, compare the name that we want against any name in the page, and based on this comparison decide whether we should look for the name in the succeeding or preceding or on the current page. The search is continued in the same fashion, namely we take the pages where the name might be, select a page and compare the name against any name from that page. When there is only one page that might contain the name of interest, then we look for name in basically the same manner. But in second case, we open the phone book in the first page, compare all the telephone numbers there against the number that we are looking for, then turn to the second page, do the same thing and so on until we find the desired number. The first case is an example of binary search, while the second case uses linear search to locate the telephone number. Obviously, as we can see, linear search is much more time consuming as compared to binary search. One might ask that why can't we use binary search to search for phone number in the directory in the same way as we used to search for name? Well, the reason is simple. The phone book is sorted on names but not on telephone numbers. With this background, we now introduce binary search. The binary search is perhaps the most famous and best suitable search algorithm for sorted arrays. Indeed, when the array is sorted, it is useless to check every single item against the desired value. Binary search is based on the divide and conquer strategy and may only be used on a sorted array. The algorithm eliminates one half of the elements after each comparison and works as follow. Locate the middle of the array, compare the value at that location with the search key. If they are equal, then we are done. Otherwise, decide which half of the array contains the search key. Repeat the search on that half of the array and ignore the other half. Repeat this process until the element is found or until the entire array has been eliminated. Implementation of binary search. The code in C for binary search is as follow. The function uses binary search to search for key in an array A containing size number of elements. We use the variables min and max for setting the search boundaries. Initially min is 0 and max is equal to highest index of the array. Mid is taken as the average of min and max. The key is checked with the value present at mid index. If it is found, we return back the index. Else, if key is smaller, we reduce the max end, otherwise we increase the min end. The while loop runs while the array is not exhausted, and this is checked by seeing that the variable min does not exceed max. If the array is exhausted and key is not found, -1 is returned. In the following slides, we have some examples of how binary search is used to search for elements present and not present in the list. performance of binary search, best, worst and average cases. In the best case, the target value is in the middle of the array. In first comparison itself, the element is found. Thus, the running time in best case is order 1. The worst case occurs when the element we are seeking is not in the array at all. Binary search cuts the search space in half each time. Keeps cutting the search space in half until the target is found or has exhausted all the possible locations. To count the number of comparisons, we calculate the number of times the loop is executed by taking an example. Suppose the list has 8 elements. Each time through the loop, half the elements are removed. After one loop, 4 elements remain. After 2 loops, 2 elements remain. After 3 loops, 1 element remains. Thus, for n elements at the most, log to the base 2 n loops will be executed. So, the time complexity of binary search in worst case is order log of n. The running time in average case is also of order log of n. Comparison of binary search and linear search. A comparison of linear and binary search reveals that binary search is much faster than linear search as shown in the following table. For searching in a list containing 1000 elements, linear search makes 1000 comparisons while binary search makes 10 comparisons. While for 1 billion elements, linear search makes 1 billion comparisons while binary search makes 30 comparisons only. In fact, the bigger the array, the better a binary search is as compared to a linear search. The only constraint with binary search is that the list has to be sorted. Before we conclude our talk, we have a look at where each of the two searching algorithms will be used. Linear search is good for arrays with a small number of elements, when you will not search the array many times, when the values in the array will be changed. Binary search is good for arrays with large number of elements, when the values in array are less likely to change. With this, I come to end to our talk on search algorithms. Thanking you.